Alright, here's our video today, solving rational equations. And let's get right to it. I'll get a clean board going here. So let's say we had a minus 2 over a plus 3 minus 1, you go 1 over 1, equals 3 over a plus 2. So remember, when we do rational equations like this, we need a common denominator. Always need that common denominator, just like you did division a long time ago. Just like division with regular numbers. Denominator. For example, if we did, let's just use regular numbers. We did 3/5 minus, who knows, 2/10. Right? The common denominator is 10. Right? 5 goes, and then what we do is 5 goes into 10 twice. Right? We find out how many times it goes into, and then multiply. And 2 times 3 is 6. 10 goes into 10 once, and 1 times 2 is 2. That's the same thing we're going to be doing over here. Just that we have these variables, and it looks kind of weird. So let's just concentrate on the left side. We'll concentrate right here on this left side first. And the common denominator is a plus 3. Because 1 goes into a plus 3, and a plus 3 goes into a plus 3. So what we can do here, you can set it up like this if you want. I can have a minus 2 over a plus 3 minus 1 over 1, right? And the common denominator is a plus 3. Just like we did over here. A plus 3 goes into a plus 3 once. 1 times a minus 2 is a minus 2. 1 goes in a plus 3 times, right? And a plus 3 times 1 is a plus 3. So that's what we get. And the common denominator is a plus 3. So we're left with, maybe we'll change the color again. We're left with a minus 2, right? Minus, because we're minusing, there's the minus sign, minus, in parentheses, a plus 3, all over a plus 3. And then we'll get to that part in a minute. So remember, when you have subtraction, you have to change it to plus. So this becomes a minus 2 plus, and you change all the other signs, negative a minus 3. And you could just get the plus out if you wanted to. Then combine like terms. A minus a, they cancel out. So you're left with just, oops, canceled the wrong one. You're left with negative 2 minus 3, so you get negative 5. Again, we'll change the color. So we're going to be left with negative 5 over a plus 3, and it's going to equal 3 over a plus 2. Right? Because that's the other part of the equation. And here, all you have to do is just cross multiply. Cross multiply. So let's cross multiply. I'll clear this out. Go back if you need to. We'll rewrite the equation. Alright, let's make sure our pen's working. Lost our pen. And we'll use that color. Why not? So we were left with now, right, we had a minus 5 over a plus 3. Right, and it's going to equal 3 over a plus 2, and we just cross multiply. Cross multiply on both sides. So this is going to be negative 5 times a plus 2, and it's going to equal 3 times a plus 3. Close or cross multiplying. Right? And when we do that, we're going to get a negative 5a minus 10 equals 3a plus 9. Now you have to get rid of the a's and the constants. It doesn't matter which ones you do. So I'll add 5a on this side. Do the opposite signs. Whatever you do to one side, you do to the other. So we'll have negative 10 is going to equal 8a plus 9. So I need a alone. I'm going to minus the 9 on both sides. And we'll bring our arrow over there. So we'll have negative 19 equals 8a, and then divide the 8 on both sides, because you want the a alone. And we now know a equals negative 19 over 8. Alright, let's do another one. Clear this one out now. Go back if you need to. So what if I had, let's do a harder one. What if I had 5 over n cubed plus 5n squared? We'll have it equal to 4 over n plus 5 plus 1 over n squared. Now again, you need a common denominator, like we did last time. But you can also look to see if you can factor, and you can factor this out. You can actually factor the n squared out, because n squared will go into n cubed. So let's factor that out first. Change the color. So we're going to have 5 over n squared, we're factoring out. So n squared, all we need is another n, because n squared times n is n cubed. And over here, all we need is 5. So we factored it out. And let's write it back in. Fix that 4. Now, you need a common denominator. Let's concentrate on the right side. Concentrate just this one first. What do you think the common denominator is? Now this can get messy, right? But the common denominator is both of them. N plus 5 and n squared is a common denominator. So what we're going to do, just like we did last time, it's a little different now. Let me see if I can make it bigger. We'll make this bigger. 4 over n plus 5 times n squared. That's the common denominator. So you're actually putting them back up like that. So in other words, you're doing this, right? It's 4 n plus 5, and the common denominator is n plus 5 times n squared. That's what that looks like. And you can put it on top like that, like I'm doing over here, or do it like this. Alright, so n plus 5 goes into this. Well, we can cancel the n plus 5 out, and you're just left with n squared. And 4 times n squared is 4n squared. Plus, and we had the n squared over here, and again we had to use the entire one. N squared goes into n squared, so that cancels out, and you're left with n plus 5. Now, we're left with this now. We're left with 4n squared plus n plus 5. So we're going to be left with 4n squared plus n plus 5 all over n plus 5 plus n squared. Sees that, right? Actually, times that. Let me fix that. It's times, not plus. Always double check your work. Get my eraser working. Hold on. And see if I can get the color back in. So it's n plus 5 times n squared. Or the other way around. Doesn't matter how you write that. So we got that part over here. Now let's go back to the left side. And by the way, if you should be noticing something there. We got the denominators to be the same. See, the denominator on the left side is this, and the denominator on the right side, I say, is this, and the denominator on the left side is the same. And since the denominators are the same, we can equate the numerators, right? So let's talk about equating the numerators. So let's get a clean page. Go back if you need to, and I'll write the whole thing out. Let's write it out. We're going to have on the left side, we had 5, and we already factored that, right? So we had n squared times n plus 5. And then on the other side, we had 4n squared plus n plus 5 all over n squared n plus 5. Okay, so now we can equate them. In simple terms, it just means now that we can say 5 equals 4n squared plus n plus 5. We have a quadratic here, so we can set it to 0 by minusing the 5 on both sides. And then we're left with 4n squared plus n equals 0. because they cancel out. So if you notice here, you can factor the n's out, right? You can factor. Now we can factor out the n because they both have an n. There's one n here and there's two there, so you can factor the n out. And that'll be n, 4n plus 1 equals 0. So we get two possible solutions, which we're supposed to have when we have a quadratic, right? So in the first one, n is just going to equal 0. You see it's by itself, so n equals 0. And then for the other one, we have 4n plus 1 equals 0. So we're going to minus the 1 on both sides, and we're left with 4n equals negative 1. Divide out the 4, and we know the other side, n, is going to equal to negative 1/4. So those are two examples on rational equations. I know it gets messy. Go back if you need to.